Hi guys, we have a question here. It's actually a jam question. It's from Jam 1991, and the question is actually the number 5. So the question says a body of mass 100 grams moving with a velocity of 10 meters per second collides with a wall. If after the collision it moves with a velocity of 2 meters per second in the opposite direction, calculate the change in momentum. So we have to take note of our parameters. So our first parameter here is the mass of 100 grams. Then we have velocity 10 meters per second, and another velocity here 2 meters per second. So we have two velocity here, given that before collision there was an initial velocity. So let's assume this is the wall. We have a wall here. So okay, so assume we have a wall here, and the body is moving in this direction. If this is a ball, you could imagine a ball that is moving in this direction. So when it gets to the wall, there's going to be a reaction force. Remember, one of Newton's laws of motion is where reaction is an equal and opposite reaction. So upon impact, once it impacts this particular point, there's going to be a reaction force from the wall onto the object that's going to push it in the opposite direction. So there were actually some options for this question. If you want to look at the options given, you can go and check your JAM physics past question, the 1991 part, and the number 5 question. This is exactly what we have there. So we have 4 options, but the truth of the matter is the option is really not so necessary. Let's say 20% necessary. 80% of the problem is you having to solve by yourself, because you are not solving by guesswork or something like that. So the first thing that we need to do in order to solve this question is to know our formula for momentum. So I'm going to write that out first of all. And momentum is the product of mass times velocity. So momentum is the product of mass times velocity. Now, as a result of this part of the formula, which is velocity, we would know that momentum is actually not a scalar quantity, it's a vector quantity. So because of this velocity part here, remember velocity on its own, it's a vector quantity. So remember, a scalar quantity are quantities that have magnitude only. Quantities such as mass, this mass here is a scalar quantity, and we have time. Time is also a scalar quantity. While a vector quantity are quantities that have magnitude and they also have direction. So you can either be going to the east or going to the west. In this case, for instance, we can see that we have 2 directional values here. Before the collision, when the object was still moving, that is at this part, we can say it was going in the eastern direction. So that's why arrows are here. So anytime you see arrows in a question, you have to be very careful, because okay, after collision it was going in the west. So mathematically, the way we write things like this to describe or to differentiate direction in one dimension here. When I say one dimension, the motion is on a straight line. So east and west. So this is one dimensional motion. So of course we can have 2-dimensional motion when you think of a motion that is when you have a question that is saying maybe northeast or north south or something like that. So that's 2-dimensional motion. You can actually have 3-dimensional motion. So in this case here, we just use the sign convention. If you take east, for instance, to be the positive side, you take west to be the negative side. So you are imagining, of course, your Cartesian plane that has four cardinal points. That is a positive and negative y-axis, and this is your Cartesian plane, something like this. Of course, you have your positive y-axis and your negative y-axis, your positive x-axis and your negative x-axis. So of course, for one, this is a 2-dimensional Cartesian plane, but remember the motion is 1-dimensional. So you have to just pick this x-axis in this case, since it tallies with the line I drew, and you assume that if the forward motion or the initial motion is positive, then the final motion is going to be negative. So we're going to since we now know our formula for momentum. Remember, this symbol here is actually a symbol for momentum. It's a Greek alphabet called rho. So RHO. So that is why I put it, it's not just P, it's actually fanciful P. So we are going to write our parameters out, because one thing with this question is you have to first understand the question. Once you understand the question, you know what the question is asking you for. Then you look for the parameters that are in the question that will help you to solve this question. So we already know our formula in this case. Then what is the question asking us for? It's asking us for the change in momentum. Now, in momentum is very interesting in physics because it relates to different other vector quantities that we know. One of them is velocity here, and the other one is force. So in fact, we have two units for momentum. One of them is kilograms. These are units for momentum. One of them is kilograms times ms inverse, that's meters per second. This is one of the units for momentum. The second unit for momentum, you can say, or newtons second, that is newtons times force times time. In this case, this is another unit for momentum. So you can see newtons here is giving force. So you can see that momentum also relates to force somehow, because of course if you look at it, force causes a change in momentum. When this object collided with this wall, what happened? There was a reaction force. It's that reaction force that caused a change in momentum. The change in momentum was a change, of course, in magnitude and a change in direction as well, because something that was going east before started going west. So it's that quantity, the quantity of change that they want you to find in either kilograms, meters per second, or newtons second. So our parameters quickly, we have our mass given in the question as 100 grams. So this is one thing I'm going to point out. When you have grams in the question, except in an occasion whereby the options on that question are in terms of grams, the right thing is for you to change the grams into kilograms. So how do we change 100 grams into kilograms? We know 1,000 grams make 1,000 grams make 1 kilogram, so we have to divide by 1,000. So we say 100 divided by 1,000, and 100 divided by 1,000, we know these two goes, so we have 1/10, which of course is 0.1. So I will say 0.1 kilograms. So our mass is, so if you were working with 100 grams, you are going to get the wrong answer. In fact, the answer you are going to get may not be in the option. And one thing with Jamb is timed. So you have to, out of the 2 hours you're given for your first subject, you have to allocate a certain amount of time for each subject. So I think it's advisable to start with your strongest subject first. So if it says 30 minutes, you know that you are going to use 30 minutes per subject, and you don't have to waste any time on any question. So that is why we are doing this revision now. So the next parameter we are looking for is the initial velocity. Remember, from this diagram here, we get an analogy that when it was going, that was before collision, there's an initial velocity, which I'm going to use U to represent. And after collision, there's a final velocity, which I'll use V to represent. So our initial velocity is what? 10 meters per second. So we have positive 10 meters per second. So we have this. So I'm going to put plus sign there. And I'm sure you understand why we are putting plus sign here. Why? Because we said it's a vector quantity and the direction matters. All right, so then the final velocity, that's if after collision, you can see the word after here, it moves with a velocity of 2 meters per second in the opposite direction. So we have to take note of this part also, because one thing with momentum questions, sometimes after collision, the object can maintain its motion in that same direction, only that there's going to be a reduction in speed. So, but let us solve this one, then I will explain briefly how you solve that kind of question. So that will be in the opposite manner. So in this case now, our final velocity will be minus 2 meters per second. Now, one valid question some people will ask is, this plus and minus here, are they arbitrary? Like, did I put them by choice? Yes, I put them by choice. We could have as well said the 10 will be negative 10, and this one, that's the minus 2 here will be plus. So if this is minus, this will be plus. If this is plus, this will be minus. So but the sign you pick from the beginning here is what you continue with, of course. So now, what is our change in velocity first of all? There are two ways to do it. We can first of all calculate the initial momentum. Okay, I think that will be more interesting. Remember, we're looking for change in momentum. So change in momentum, I would say change in momentum, I can just use a symbol, is going to be equal to the final momentum. I don't want to use the long, so I will just say my final momentum minus my initial momentum. So some people can calculate the change in speed first of all, the change in velocity, which is final velocity minus initial velocity. Then the answer they will get, they multiply by the mass. But I think that will be faster. But at the same time, you can calculate the individual momentum separately, and then you are going to subtract them. So final momentum will be, of course, I would say mass. Since mass is the same thing, I would say mass times v. This is final momentum. Then our initial momentum is going to be mass times u. I hope this makes sense. So of course our mass remains unchanged. Our mass is giving us 0.1 kilograms. We have 0.1 times, what is our v? Our v is minus 2. I will just leave out the units for now, since we already have our final units here. Minus our initial momentum, our mass is still 0.1 times, and what is our initial velocity? Sorry about that. In this case, our initial velocity is 10 meters per second. So I'll just leave it out. So I did not put any sign here because it's positive. So when we simplify this, here we have what? We have minus 0.2. Yes, minus 0.2. And here we have minus. Okay, here what do we have? 0.1 times 10 will give us 1. So if we simplify this, we have minus what? Minus 1.2. Either you use Newton S, or you say minus 1.2 kilograms meters per second, just like this. So this is the final answer that you will get. So now, I remember in the options given in the JAMB past question did not have this negative symbol here. So our negative symbol here is because of the sign convention we choose at the beginning here. For example, if we have chosen the initial momentum, the initial speed, here, or the initial velocity to be having a negative sign here. So if I've given this minus 10 ms, that means I would have given this one plus. That's the final velocity would have been plus 2 ms minus 1. So what that implies here is that I said that initially my object was going in the east direction rather than in the west direction, and after the collision, my object changed direction to the other side, to the positive side. So, but you know that since this was not what I used, you can see from my diagram, I used positive as my east, and I use negative as my west. You can look at the Cartesian plane here. So that is why I'm having a negative symbol here. So what this negative symbol is saying that after the collision, the object changed direction. If this was positive, as well as the initial momentum, which was positive here, you can see this is initial momentum. This is initial momentum. The value we got here, 0.1 times 10 is a positive value. It's only the final that is negative here. So I would say it's this final that kind of affected this initial. So if it was initial, if the answer we are getting here is positive also, it means that there was no change in direction. So an example of that would be if the question said it moves with a velocity of 2 meters per second in the same direction. So we know that there was something that maybe it collided with a paper wall, or a wall that was not rigid enough to make it change direction. You understand? It could be maybe a tarpaulin or something like that. So it will still puncture through that obstruction and maintain motion in the same direction. So we have to be very careful. Remember, the most important part of this question, like I said, is knowing that your formula, knowing that you have to change your mass into the standard unit, which is kilograms, then knowing the sign convention the sign convention for vector quantities such as force, such as velocity, and in this case, even momentum is having what? A change in sign here. So this is the final answer. Thank you for watching, guys. If you have any question, any jam question, you can send it to my email. I'm going to keep my email in the description box so that we can solve. We are looking at science subject, even non-science subject, you can bring it so that we'll prepare before next year. Thank you.